Good morning all. So today we will study the RLC circuit to understand its phasor diagram. So we will study the phasor diagram for RLC circuit. Now, if we want to understand the phasor diagram of any electrical circuit, we have to know what is phasor diagram. So, in very simple way, we can tell that phasor diagram is a graphical expression or graphical presentation. What is graphical presentation or graphical representation? The procedure of presenting in a graph or in a form of a graph or in a form of a picture. So, graphical presentation of phasors. Now, here we have to know about the phasors. So, the question what will come in our mind that what are the phasors? So, we are discussing in the domain of electrical engineering. So, definitely we will discuss the phasors for electrical quantities. Now, we know electrical quantities like V and I are sometimes found as the sinusoidal quantity. And how we can realize that lagging and leading in the time axis or omega axis or omega t axis, where we can get the representation of the sinusoidal quantities like V and I with their time varying form. So, the phase angle or phase displacement is also possible to show in the time varying representations. So, if we have one sinusoidal curve and we can define the time axis as the horizontal axis and the vertical axis will be the amplitude axis. So, we can say it's a voltage signal. So, it will be Vt, function of t. Sometimes it is also possible to represent the axis as omega t form, where omega is the angular frequency and this angular frequency is equal to 2 pi f. So, this is well known to us. So now here we can see that the amplitude of the signal Vt is changing with time, and if we get different time frames, so we will get different values, and these values will be the data or data points along the time t. So it can be considered as t equal to 0, that is t0, this one, then t1, then t2, t3, like that we will get tn, and we will be getting a lot of values. So in the time frame or time axis, we can get the different values of Vt whenever we will move towards the time axis. So at t1, at t2, at t3, there will be different. This will be V1, this will be say V1 volt, and this will be V2, this will be V3, like that we will get all these data points, and if we join that in a graph paper, we will be getting the entire sinusoidal signal. So this is the basics of sinusoidal signal, and with the form of which the electrical quantities are generally found. Now, if we have more than one signal in a same time axis, then how we can understand the lagging and leading phenomena? So first of all, we should know, or we should remember, that the angular displacement or angular difference between two electrical quantities is called the phase angle or phase difference. So what we understood in the phasor diagram. Now if we want to draw the sinusoidal waveforms, so the sinusoidal wave which start from 0 will have the 0 phase angle with reference to this origin, and we can divide this time axis, or let us consider this omega t axis, and omega t, this omega t is nothing but the angle, because we know omega is radian per second. So if we multiply omega with t, that is also second, so we will get radian, and that is nothing but the angle. So we will call this point as 0, this point as pi by 2 radian, this is pi, this is say 3 pi by 2, and this will be 2 pi. Now this time axis or omega t axis can be taken as, now this vertical axis is the amplitude axis, so it will be Vt. So if this is a signal, say A, then A can be written as Am sine omega t. As this is the signal taken as the reference here, because it starts from 0, so it will have 0 phase angle displacement. And now if one signal starts from pi by 2 and it also follows the sinusoidal form, so it is also possible, say it is called B, it is also possible to be represented by a sinusoidal waveform equation. So Bm sine omega t minus phi or theta. Here the displacement from the reference signal is phi. This is the phase displacement between signal A and B. Similarly, if we find any signal starts before the signal A in time frame and it moves like this, like another sinusoidal wave, and if we call it as C, then we can also present it with its sine wave equation. So Cm sine omega t plus phi. So here the signal C is called the leading over signal A and B both. So signal C is leading over A by an angle, say this is also phi, it may be phi 1 or phi 2 also, we can name it with our own choice. So we can see that this is before the signal A by an phase angle phi, so it is called a leading signal leading over A by an angle phi. B will be called a lagging signal because it starts after A. So whenever we will go leftward direction from the vertical axis, from the 0 point, we will call that is leading phase. And if we move from rightward direction from the vertical axis or 0, it will be called as lagging phase. So lagging direction we can tell. So signal B is lagging behind A by an angle phi, or if we call it phi 1 and phi 2, it will be good to distinguish. And signal A is lagging behind signal C by an angle phi 2. So we can also tell that we can compare between C and B, that C is leading over B by an angle, say phi 1 plus phi 2, and also similarly we can tell that B is a signal which is lagging behind C by an angle phi 1 plus phi 2, because this angular displacement, total angular displacement from this to this is nothing but phi 1 plus phi 2.